Welcome back to Generative AI 101, the show where we pull back the curtain on artificial intelligence and generative artificial intelligence and show you what's really going on behind the hood. I'm your host, Emily Laird, and today we're going deep into the nitty-gritty of how AI image generators are trained. You know, those stunning AI-generated artworks you've been seeing, probably playing with. Stuff that looks like a creation by a modern Picasso or maybe a highly caffeinated surrealist. Well, there's a lot more going on there than just throwing some code at a computer and hoping for the best. We're about to unpack the complex and surprisingly human process behind training models like DALL-E, Midjourney, and Stable Diffusion. You'll walk away knowing how these models move from here's a random collection of pixels to wow, that's art. And spoiler alert, it's not magic. It's a meticulous process involving mountains of data, staggering computational power, and a fair bit of controversy. Welcome to Generative AI 101. All right, let's get into it. So at the core of AI image generation is data. You've heard me say this a lot on this podcast. Lots and lots of data, heaps and mounds of it. So picture this. To train an AI to generate images, it's like teaching a toddler how to talk. You don't just throw them a dictionary and hope they've figured out. No, you show them pictures, repeat words, and slowly they start understanding the connection between what they see and the words they hear. AI works similarly, but on a mind-boggling scale. So these models learn by processing tens of millions of image-text pairs scraped from the web. So imagine feeding an AI a picture of the Eiffel Tower alongside the caption, "A large iron structure in Paris." Do this millions of times with all sorts of images, cats, trees, unicorns, abstract art, 19th century oil paintings. And the model starts to understand the link between words and images. The more data it consumes, the better it gets at knowing that sunset over the mountains should look more Bob Ross than Jackson Pollock. But here's the kicker. So the data isn't always clean or well organized. Some images have misleading captions, others are outright strange. And when we really dove into this for image training, we found that a lot of the internet just didn't have alt text, right? Those captions that are associated with the image. So part of the training process really involves data filtering and augmentation. This is like curating a museum exhibit. You don't want junk. Okay, the AI needs diversity, everything from Renaissance paintings to random selfies to make sure it can handle a variety of requests. But you also have to filter out noise, the blurry, irrelevant, or mislabeled content. Then there's red teaming. You also have to filter out the inappropriate, okay? Because we don't want our image generator creating things that could get you arrested. All right, so let's talk diffusion models. We've talked diffusion models when we kind of entered into the GenAI image generation space, but if there's one thing you remember from our previous episode or this episode, let it be this. Modern AI image generation is largely powered by diffusion models. They're the secret sauce, okay? Behind models like DALL-E 2, DALL-E 3, Stable Diffusion. And they're not just another algorithm, they're a breakthrough in how we teach machines to generate images. So here's a simple way to think about it. A diffusion model starts with random noise, like the static in an old TV, okay? It then reverses that noise in tiny steps until a coherent image emerges, pixel by pixel. Think of it like watching a Polaroid photo develop, except it's happening through trillions of calculations. Every step it takes, the model is refining its guess, honing in on what the final image should look like based on the input prompt. So why diffusion models and not GANs, or generative adversarial networks? We talked about it in the earlier episode. Well, GANs were a game changer for realism in AI images, but they're notoriously unstable. You'd get beautiful images one minute and complete garbage the next. Diffusion models, on the other hand, are way more reliable. They generate consistently high-quality images and are easier to scale, which is why they're dominating the scene right now. Okay, so here's where things get a little meta. So when we say these models learn, we're talking about something called self-supervised learning, which sounds like AI is just hanging out, but we've talked about this before, okay? The nuance is it's still supervised. It just gets its supervision from the data itself. So every image comes with a caption. That caption is essentially a cheat sheet for the AI. The process is a bit like training an artist who never went to art school but has access to thousands of paintings with detailed notes about each one. So the AI looks at millions of these image-text pairs and begins to understand relationships. So this blob of pixels next to that blob, well, that's probably a face. And if I see the word smiling, I should make the lips curve upward. You may have done this in art class when you were younger or maybe in college, where you take an image and you break it down pixel by pixel and you try to put it back together. When I was in school, I had to take this art class and we had to take paint samples, like, the printed out paint samples you get at a store, and we would chop them down and we would use the different paint colors to build an image, okay? So it's a similar practice. So this self-supervision is key to unlocking the model's ability to generate creative content from scratch. It's why when you type in a futuristic city at sunset, the model doesn't just slap together a random cityscape. It knows what elements of the scene should look futuristic, and it understands how to recreate a sunset's color and shadow. Now, if you're familiar with AI like ChatGPT, you've probably heard a lot about reinforcement learning. That's where humans jump in and rate the AI's responses, okay? AI gives an output, a human says, that was good, that wasn't good, guiding it toward better answers. But in the world of image generation, reinforcement learning doesn't play as big of a role. Sure, it's used in some models to refine images based on human feedback, but it's not the driving force behind these masterpieces. Where reinforcement learning does come in is in those human-in-the-loop moments, where users help the AI improve by giving it a thumbs up or down on generating images. This feedback loop can help fine-tune the AI's taste, but it's more like adding seasoning at the end of a recipe. It improves the final product, but isn't the main cooking method. All right, let's pull back the curtain even further. So you've heard me talk about how these models are trained on huge data sets scraped from the web. But this raises a couple of big questions. What if the data is biased? What about copyright? All right, so first let's start with bias. Since these models learn from public data sets, they absorb all the good and the bad in those sets. That means biases around race, gender, culture can definitely sneak into AI's outputs. Ask for an image of a CEO, and the model might serve you a bunch of middle-aged white men in suits because that's what the training data has shown them. The AI isn't doing this out of some intention, it's just reflecting the patterns it's been fed. Second are copyright issues. And we could do a whole episode of this. So these models are trained on publicly available images, many of which were created by artists, photographers, and designers who didn't exactly sign up to have their work used this way. There are real concerns about whether AI is infringing on creators' rights when it generates images based on this training data. It's a legal and ethical debate that's far from being resolved, and something the AI community is grappling with now and will into the future. So where does this leave us? Well, AI image generators are a jaw-dropping example of machine creativity powered by absolutely mind-blowing amounts of data and computational power. The models are getting better every day, and while the fusion models are leading the charge now, who knows what's next? Maybe in a few years, we'll be talking about a new architecture that makes diffusion models look like child's play. Probably will. What's clear is this: understanding how these models are trained gives us not just a glimpse into the future of creativity, but also raises crucial questions about bias, ethics, and ownership in this brave new world of AI art. That's it for today's episode of Generative AI 101. Hopefully your brain is now stuffed with enough knowledge to hold its own at a dinner party, or at least impress your friends with some AI trivia. If you got thoughts, ideas, or just want to connect, hit me up on LinkedIn. I'm Emily Laird, Laird, and let's keep the conversation going. Until next time, stay curious, stay adventurous, and remember, you know more about how generative AI image generators are trained now than you did when you arrived.